Okay, hello. Consider the plane that passes through the points something, something, something. These 3 points. Find a normal vector to that plane. Okay, so my answer will be a vector for part A, and then find the equation of the plane. And so my answer will be an equation for part B. Okay, so first, a picture. Maybe I'll call it a cartoon, because I'm not actually going to draw these points precisely, but I'll just draw my 3 axes, and maybe I have like some point here's a point, here up higher is a point, and somewhere over here is a point. Okay, so those are 3 points in 3-dimensional space. And now let's give them names. How about A, B, C? A, B, C. And now there is a single plane that passes through all 3 points. It's hard to draw it, so I'm not going to draw it. But what I will draw is a vector pointing from A to B in purple, and a vector pointing from A to C in green. I could have based it all, so these 2 vectors are sort of based at the point A, but I could have based them at B or based them at C. And so what do? Well, first, what is this vector? Let's call this V. The purple vector is V. And what is V? Well, it's B minus A. Final minus initial. I'll write that down. Final minus initial. That's what I sort of repeat to myself when I try to figure out how to write down a vector. So V is, well, what's B? I look up to my problem and I see B is that. A is that. Okay? So I can do this. 3 minus 1, -1 minus 3, 6 minus 2. Great, so that's V. And now let's give the green one a name W. So what's W? Well, W is C minus A, final minus initial. C is 5, 2, 0. A is 1, 3, 2. Okay, I can do this. 5 minus 1, 2 minus 3, 0 minus 2. Okay, so now I have my vector V and my vector W. And both of those vectors live in the plane. They span the plane. But what's the normal vector? Well, an easy way to do this, because we are in 3-dimensional space, it only works for R3, is the cross product. So let's call N to be the vector V cross product W. Now, how do I do the cross product? So I put I hat, J hat, K hat in the first row of a matrix. I put the components of V in the second row. Those are 2 minus 4, 4. I put the components of W in the third row. 4 minus 1 minus 2. And I take the determinant. And so one way to see this is the I hits these 2. Positive here, negative here. And so I have I hat times minus 4 minus 8. Plus, I have J hat times, okay, now what's J hat? J hat will get what is it? Okay. These ones positive, so that's 16. And then minus, is it those ones? Yeah, it's minus those ones. So 2 times minus 2 is minus 4. So I have a minus 4. Why don't I just put that in? Yeah, minus 4. Okay, and then plus K hat times, now K hat will get sort of this box, it has positive here, so it'll be a -2 with a plus sign. And then minus what I get there, so it's minus 16. Minus 16. Okay. So that means I have I hat times -12, j hat times 16 plus 4, k hat times -2 plus 16. And then remember that I hat is just 1, 0, 0, j hat is 0, 1, 0, k hat is 0, 0, 1. I also call them E1, E2, E3. And so my end result is the vector -12, 20, 14. Okay, this vector, because it's the cross product of v and w, it points orthogonally to v and w. So it's 90-degree angle with respect to v and a 90-degree angle with respect to w. And so that will be our vector n, and this is the normal vector. Normal vector. Okay. That's part A. How do I get part B? Find the equation of the plane. Well, if I have a normal vector, then the plane is going to be n dot x for x some variables. And so essentially I just put these numbers in front of my three variables. So let's say -12 x1 plus 20 x2 plus 14 x3 equals some number. And the question is, what number? And so we don't know, just knowing the normal vector to a plane only gives us the tilt of the plane. It doesn't tell us how far off the origin we are. But we know that there's 3 points on the plane. So if we plug in any one of these points, we should get that same number, this right-hand side. And so, for example, the point A is 1, 3, 2. Plug in A equals 1, 3, 2, because this, we know that this point is on the plane, so it should satisfy this equation. So when I plug it in, I should get this correct number. And that gives me the shift off the origin. Remember, the origin is 0, 0, 0. Origin is just the name for the point 0, 0, 0. Okay. So plug in A. So I have -12 times 1 plus 20 times 3 plus 14 times 2 equals, and that will be this number. Okay, so I can do this, 28, 60, and -12. Okay, this is difficult. I don't know why. I'm going to do -12 and 28 together to give me 26, 16. 16 plus 60 is 76. Okay, so this is 76. This number should be 76. And this is the equation. And let's just check. I mean, if we had plugged in the point C, 520, let's try to plug in 520. And just make sure that we didn't make a mistake. Plug in C equals 520. It should give 76, right? Otherwise we made some kind of mistake. -12 times 5 plus 20 times 2 plus 14 times 0. Well, that's easy. And here I get a 40, and here I get a 60. Uh-oh, did I make a mistake? I must have -20. So I got -20. That's bad. Why? Where did I make a mistake?